Alright, time for another DraftPhysics.com video presentation. So, Franklin Who is back. Okay. I actually unsubscribed from him and was pretty pissed off. Because I think, this is a long argument, 2-year argument. And he injected himself with a simplistic pile of crap that's been dealt with 50 times now, at least. And it's just not part of the story, in my opinion. So this mathematical derivation based on F equals ma and work equals F times distance. The argument is, first off, F equals ma isn't Newton's equation. And second, the work equation was invented in 1842, and at the same time as they decided to fix mv squared, which was getting completely, insanely silly wrong answers. So yes, it's all contrived math. Now maybe you don't know what contrived means, but yes, it's just math manipulated for the purpose of producing something that looks like consistency, but it isn't. Because the evidence, the actual physical experiments, don't support it. Now, the biggest problem with the whole history of this fable is that the fable was rejected. Leibniz was the inventor. He was buried as a nobody. He had completely lost all scientific reputation. No one showed up at his funeral. No one. All right. Newton was buried as a god. So clearly momentum had won the argument. All right. And it was dug up by this French woman 20 years later, 20 years after their death. And popularized with really bad experiments, dropping crap into clay. Like clay is somehow a great judge, that clay treats fast things the same as it treats slow things. That's the assumption. Well, it's a silly assumption, and clearly I can make the clay any consistency I want and change how far something goes into it. Really bad. And sand experiments, right? So, these are all part of already the story. But the idea would be is obviously a fast thing can hit a bucket of sand. And the fast thing will, just by contact, give things that it hits more speed. Because it's going faster. So they have more energy. So it gives a few particles a great big deal of energy. But it doesn't give a lot of particles energy. Where something heavier, hitting the sand, moving slower, won't shoot sand as far because it can't give it velocity faster than it's moving, but it will move a lot. It'll move the same amount of sand in total distance. It'll just move more sand particles shorter distances, where the lighter, faster object moves fewer sand further. But it's the same amount of sand moving the same distance. And the point is that these rickety experiments are what took science down this silly path. And now we're just doing more rickety experiments. And it should be just kind of glaring. The big ones are, hey, it takes 4 times the energy to go twice as fast. Now, if that were true, it would be well established already. And everybody would be giving it advisories about how don't drive down the highway at 60 miles an hour or 80. Because, man, are you losing gas. No one's saying that, are they? That's right. No one is saying it because it's not true. It's a simple truth. Now, I gave you, you put my name in the title. If you're going to put my name, DraftScience, in the title, then why don't you argue my arguments? If you're going to argue somebody else's arguments and you're going to do something else other than answer the things I directly ask you, which is diagram a lever. It's one of the simplest devices in the world. You just take a stick and you put a fulcrum and you move things. The fact is the lever converts momentum. It takes slow, heavy things with a certain momentum and converts it into a light, fast thing with the same exact momentum. It converts energy. But by the kinetic energy theory, it makes free energy. Because if I push the slow, heavy, I create on the other side with the lighter, faster, free energy. Just like the gun barrel is making a bullet that has 2,000 joules of energy, yet the barrel of the gun going the equal and opposite reaction, it's supposed to be an equal and opposite reaction, right? It only has 2 joules. 2,000 to 2. And people think that's energy conservation. How can it possibly be energy conservation? How can that possibly make any sense that there's any more energy going that way than that way? It violates Newton's third law. Now, these arguments are explicit. Answer these theoretical arguments. The theoretical arguments end the conversation for rational people, in my opinion. Only irrational people can cling to mv squared or 1/2 mv squared if they deal with these theoretical questions. Okay, I'm in a spaceship. I, shoot the dime out at 1,000 miles an hour, and I shoot the the 2 kilograms out at 1 mile an hour. It's 2002, something like that. One, yeah. So 2001, because we're inverting the masses. But anyway, and the argument is somehow what? I've got 2,000 joules going one way, 2 joules going the other way, and somehow the spaceship turns? No, it doesn't. The spaceship says this is the same amount. Momentum this way is the same as the momentum that way. So I've tried to put this into these arguments. And again, the lever argument, the gear argument are decisive in my opinion. If somebody came up with a glimmer of a counter argument to how what I said is not true, then they'd have some viability here. But there's no viability. I've diagrammed how their theory creates perpetual motion machines, okay, free energy machines. Nobody has provided a single glimmer of an argument explaining how the machine shouldn't theoretically work. Why doesn't it physically work in the real world? If kinetic energy is true, why doesn't the machine work? And nobody's been able to draw that line. All right, but I'm just saying, so yes, it's nice that you did an experiment, but this is littered with bad experiments and bad logic applied to experimental theory. I mean, how do springs compress? How do springs expand? They're all facts. So you just did an experiment where you got a lot of things wrong. So you're going to have to correct yourself again. So this is sort of hurting your own credibility. It's like, she loves me. You're just picking daisies, right? All I do is pick the right day, and Franklin agrees with me. I pick the wrong day. He doesn't agree with me. What's the point of that? I mean, are you just going to end on she loves me, and you're just not going to go through the rest of the daisy? Because that's essentially, you keep switching, you just don't seem very reliable. So for your own benefit, I would say, you have to get into the theoretical argument before you start doing experiments, because you made 2 glaring errors. The first one is not understanding that it's about how long you're in gravity, and when you're getting accelerated. It's a constant rate of acceleration, not a constant force. It's a constant acceleration, because the force is constantly applied to the acceleration you already have pre-existing. And so it's about the amount of time, and a ramp twice as high doesn't take twice as long to travel. So you have to go 4 times higher to get twice the amount of time traveling down the ramp. You want to travel twice the amount of time down the ramp, you have to go 4 times higher. All right, and that'll double your velocity. And now you got an outcome, though, now that's going to tell you, well, if I went 4 times as hard, the car's going to go 4 times further. Well, that's because friction, okay, isn't a constant force. Friction has a huge bias for fast things. It lets fast things off the hook, okay? The faster you can travel, the less friction there is at the road. It's just a fact. Your tires make less contact with the road. They spend more time in the air. So you can think of it, the ideal one is, I think, boats, right? So boat racers don't spend very much time in contact with the water. Okay, most of the time they spend in the air. So there's less friction in the air than there is with the water. So they hit little tiny ripples in the water and fly in the air as far as they can, and then hit a little ripple, then fly in the air. So they are reducing their contact with the water. So speed can do that. And so friction is a really poor way, like clay, to measure something's energy, because it has a bias. The friction sucks up more energy from things moving slow than things moving fast. And it's just a fact of how friction with contact, gravity pushing you into a surface, well, it doesn't push you, it pushes you evenly, but the surface doesn't treat you evenly. And you don't dispense your energy to the surface evenly. So the more time you can spend above the surface, bouncing, off the surface, the more time, okay, you won't be in contact with the ground, and the more time you'll save, the more energy you'll save. So yeah, fast cars don't make as much contact with the road, and therefore, okay, they're not going to be able to incur the same number of friction losses. And the same is true for bearings. Bearings work better the higher the speed. So I mean, I want to. All right, so I'm going to play your video, but it's in this context that I put down these arguments. So can we just isolate to the lever argument or the gear argument, which is still the lever argument? I mean, everything turns into levers if you really think about it, but whatever. It's all just what's being converted, all right, what's being transferred between objects. And the fact that there's no evidence of kinetic energy is, to me, pretty glaring, that you have no good experimental evidence. And the fact is they do have some experiments where they actually produce free momentum in a direction. All right, that's another thing to deal with. But let's just deal with the lever. Like I said, to me, it's a decisive argument. So I'm just saying, you're saying you don't understand the lever argument? I don't understand what the problem is. I put a light object on one side. I have a heavy object close to the fulcrum on the other side. They balance. Okay, there's a scale. It's actually a balancing scale made, traditional scale is made that way. You can use little tiny weights over here to tell the big weight over here. Okay, because these weights, okay, will balance to that weight because you've put them further out on the lever. But the fact is those little weights have the same energy. And by kinetic energy theory, they have much more energy. So any movement on this side will create free energy on this side. Well, anyway, I already made the argument. I just think if you're going to say you're responding to DraftScience, you ought to respond to my arguments. All right, so let's play his video. So his video makes two fundamental mistakes. The first mistake is, you can't. I made this mistake one day, when I was full of myself. And it's a mistake to avoid. I mean, I shouldn't have made it. It was it wasn't like it was a I always thought so mistake. It was one of those, one day I just was, thinking one way that I already knew wasn't right. Well, anyway, so the argument is that when you're going through gravity, as you go faster, okay, you're in the gravity less time for longer distances. So, this is Galileo. So as you fall, it's by this ratio, okay, 1, 3, 5, 7, it's all odd numbers. So the amount of distance you travel in 1 second, okay, changes. And so to go twice as fast, okay, you have to go 4 times higher in the gravity to get twice the velocity. So that's for even objects of the same mass. So if I have 2 objects of the same mass, and I drop them, all right, and I want to double the velocity, I have to actually do the 4 times the distance. Okay, I have to have 4 hunks of distance because I want to make it twice as long in the gravity. So to be in the gravity twice as long, because of this, okay, because as I go faster, I'm covering more distance. The fact is, in the first second, I only do this little tiny bit. In the second second, I do this 3 part. So I only do this in the first second. I do this giant 3 in the second section. So now I got my 4, which is going to double my velocity from the one that's just dropping this 1 unit. Yeah, so here's where double would be. I don't know why. Yeah, well, the total is 4. Yeah, okay, we don't need this. I only drew that because my perspective was off. Anyway, so you have to go 4 times higher to be in the gravity twice as long. So let's just understand. All you're trying to do is be in the gravity twice as long. All right, and that'll give you twice the velocity. You can't get twice the velocity any other way than to be in the gravity twice as long. But the distance won't guarantee it because of the fact that as you go faster, you're covering more distance. So anyway, so it has to be, if you want to double the velocity, you go 4 times higher. So your ramp has to not be twice as long. It has to be 4 times this distance. So you're 4 times this distance. So you have to be 4 times higher. Right, so you can't go by the middle of the ramp. That won't tell you much. You can't drop it from the middle of the ramp. You have to drop it from this distance versus this distance to get these height distances. So that's all you care about, is that this height has to be 4 times higher. So you drop it from 1/4 and then you drop it from the top to get the ratio of twice the velocity for this one. So you want to double this one's velocity, you have to drop it from this high. All right, but then again, you're going to get results that say, whoa, the car goes 4 times further, or 3 point, it'll end up being 3 something. It never comes out to be 4. But anyway, but that's because friction cheats. So again, it's just a clay experiment. It's another bad experiment, not very logical, not understanding that friction isn't the way you decide, because friction cheats for fast things. So you can't use friction to collect the energy. And understand, you are collecting it. It's like you put up a bunch of bowling pins. All right, and the fact is that the bowling pins they're going to cheat, okay, in favor of the faster object. So I can't really make an example of how that cheat happens with bowling pins, so it's probably not the best analogy. But the fact is that you're going to be giving your energy to the ground, all right, and you're going to give it based on contact. And the faster you're going, the less contact you're going to have, and the less you're going to give it away. So you're going to have an advantage if you're going faster than if you're going slower, just because of the unevenness of friction. Yeah. So what else? But I'm just saying there's glaring truths, okay? It's a glaring truth that you already know, and I really don't have to explain to you, that you do not use 4x more gasoline, okay? That's what 1/2 mv squared says. It overtly says it. It must be true. 4 times more gas to go 60 miles an hour than 30. Okay? That's their statement. That's what physics says. All right? There's no explanation for why that wouldn't be true. That's a fact in their opinion. And they don't have a single experiment showing it. Isn't that enough for you to be quite sure that, oh, right, momentum is right? Again, all of Newton's mechanics got correct answers, and they're saying Newton was wrong. Can you get it? How do you fix Newton? Do you fix Newton by squaring the velocity? No hope of fixing Newton. That'll just break Newton. NASA doesn't use 1/2 mv squared. It understands momentum. When they're in space, they know perfectly well it's just about how much momentum I shove out of my spaceship will decide where my spaceship goes. I already said all this stuff. I mean, so if you're going to say you're responding to me, respond to my actual arguments. You know, please. Because until I get answers to those arguments, I'm convinced, okay? I'm not going to be convinced because you roll a toy car down a piece of cardboard. That experiment is not going to be good enough. All right. So we'll play the car rolling down a piece of cardboard. Okay, so we don't need this. All right. Again, I like Franklin, but this is sort of bullshit.
Hello and welcome back to my science channel. So Gary of DraftScience has been going on and on about how kinetic energy is not 1/2 mv.
And I've been going on and on with pretty much the same arguments, just trying to perfect them, and nothing's really changed. I mean, in a year, nothing. I mean, I did add the lever argument. I had the spaceship argument. There was a few other arguments. I mean, the 4 times more fuel arguments. These are arguments. I have gotten no rational response to any of those arguments. So I'm not going on and on over nothing. I'm going on and on because nobody will address a single one of the points made. And then I could go into the history. Again, the history is so bad. The arguments made 300 years ago were so pathetically stupid, it wasn't even close to a physics argument. So in the atmosphere where they decided this, there wasn't anything close to a rational description of anything.
V squared. Perhaps it's mv, which is just momentum. But he is absolutely correct that you cannot find one single experiment which objectively measures with.
Yeah, that shows the bullet doing 2,000 joules worth of manipulation. Moving 2,000 joules worth of matter, and showing the gun barrel only moving 2 joules of matter, making 2 joules of heat. So if it was a heat equation, the bullet is supposed to have 2,000 watts of energy, and the gun barrel only has 2. How can that possibly make sense to anyone?
Measurements to show that the kinetic energy formula is in fact 1/2 mv squared, and the squared makes a big difference. So if you're just,
well, as it pointed out with the bullet example, and I could go all the way to the electron, and then you'd really understand how silly the argument gets, because the electron has insane amounts of kinetic energy, okay, because of its tiny, tiny little mass and its squared velocity.
going say twice as fast, 2 squared is 4. So the amount of kinetic energy of an object going just twice as fast should be 4 times as much, which is, kind of hard to believe.
Well, it's easy to believe if you do experiments poorly, and that's about all you can say. But yeah, if you do experiments, recognizing all of the variables in the experiment. But yeah, I mean, they did. I'm just saying, they obviously were able to drop things into clay and say, look, the thing going twice as fast bent the clay 4 times as much. And then they would drop things into sand and say, look, the thing going, twice as fast shot sand 4 times further. And it's really, they're theoretically mushy experiments because they're logically flawed.
So I wanted to come up with the simplest experiment I could think of to show whether.
Well, see, we've all been there and done that. So I've already done this. The first thing you're doing is you're using gravity, which sort of, it doesn't fail to create double the velocity, but you have to do it right to create twice the velocity. All right, so I just used rubber bands to create the same amount of force, and I used 1/2 the weight objects. All right, and didn't find the kinetic energy to be correct.
This was either mv squared or mv. Now the only other experiment you can find on the internet is like the air table collision things, but as I showed in my previous video, whether you use mv or mv squared, they both end up being equal.
Well, they really don't, but whatever.
So that kind of experiment cannot actually tell the difference between mv squared and mv. It's useless as an experiment to do that.
No, it isn't. But whatever. You're just looking for something where you're going to eliminate biased functions. So you're just trying to say, so if we take away the friction, if we take away all these things that are getting in the way of us seeing the energy, then we can measure it as just an impact energy. I'm just saying, if I made a lever, okay, and I have a 10-ton train going 5 miles an hour hit one side of the lever, and a 10-ton train going 5-ton train going 10 miles an hour on the other side, just inverted, what's going to happen? If I plow the 10-ton in and I have the 5-ton on this other side of the lever twice as far out, I say logically we know the 5-ton's going twice as fast. And logically the inverse is going to happen. There's no doubt what the lever is going to produce. So I'm just saying, in my opinion, that's a decisive argument because there's no explanation for going one way, I lost half the energy. That is, when I put the 5-ton train and made the 10-ton train leave at half the velocity, I lost half the energy. And when I put the 10-ton train in and I got a 5-ton train leaving with twice the velocity, that somehow I made free energy. No, I didn't. I didn't lose half the energy in one direction. I didn't gain half the energy in the other. I mean, the lever, again, it's just this, it proves the case. Diagram the function of a lever. A balance.
So this is what I propose. I'm going to propose that since Gary likes cars, I have a car. So I have my model Corvette here, okay? And we're going to set my model
You could take the real car out, but anyway.
Corvette going at some speed, right? And so the thing is that if I get my Corvette to go, say, just twice as fast, then it should have 4 times the energy. And what I'm thinking is that I'm going to roll this down.
So if he had done it right and put the car 4 times higher, he would have gotten a lot more than twice the energy, because he's measuring it based on friction, and friction has a bias. So it's like the clay experiment. It's just guaranteed to give you the wrong visual answer. So it'll tell you something, but it's not telling you, if you're smart enough to know, friction isn't fair.
On my floor, and we're going to go and find out how far it goes. So let's take a look at this setup here.
I mean, that's the whole point. That's the whole reason why you have to take friction out of experiments, is because it it isn't fair. It cheats. It's a lot tougher on the heavy, slow thing than it is on the light, fast thing.
Okay, so this is the simplest thing I could think of. So what I've got is I've got a ramp here, and I've marked the halfway point here, right? So no matter what angle I put.
So he had to mark really the 1/4, because it's 1 to 3 will be the ratio. You're going 4 times higher, so it's going to be the 1/4 mark versus the total distance.
This is not, or matter how my ramp is built. Theoretically, if I start my car here, it should go through the gravity potential twice as long and obtain twice the speed of if I put it halfway. So that's the basic principle. And then we're just going to see how far the car goes, okay? And we're going to see whether if it goes like 4 times further when I just use the middle mark versus the top mark, okay? That would be the prediction, okay? So let's just give this a try. So I'm going to put the back wheels right on that mark there. And I'm just...
So, obviously this is just all bad theory, blah, 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 it's wrong. And I understand him doing this because he doesn't want to really watch 500 videos. But you really don't have to watch 500 videos, right? I mean, I do have the videos pretty well organized, and I mean, I have a page called, debate.com. There's lots of kinetic energy videos there, and they're isolating arguments. And, he's just sort of ignoring that. The conversations between me and Toady cover all of these irregularities in the evidence.
Gonna let it go. There it goes. So the thing is that as the car rolls, it's going to absorb the kinetic energy.
Right, the ground is going to absorb it, and the fact is the ground doesn't absorb it evenly. If it's the faster you can get it going, the less friction per foot it will incur.
So theoretically, the amount of kinetic energy the car has should correspond to exactly how far it goes.
So theoretically that's wrong. Okay, so how far something goes in clay. Like I said, I can throw things at cornstarch, right? And because of the nature of cornstarch, it reacts, it hardens. The atoms bond to each other with motion. So the more motion there is, the stiffer the substance gets. So the faster object will essentially be totally, might even bounce off of the kinetic of the cornstarch, where the slow-moving object can go right through.
Which is just under 6 feet. Okay. So let's give it theoretically twice the velocity by putting it up twice.
Alright, so again, this is a mistake I made. It's just, just a mistake. It seems logical. You go twice as high, it's twice as much, blah, blah, blah. And it really isn't, because you have to think about the time the car is going to spend on the ramp getting accelerated. And the fact is that you're not doubling the amount of time it's rolling down the ramp. You're doubling just a rolling distance, but you're not doubling the amount of time gravity is working on the car. And to double the amount of time gravity is pushing on the car, you have to go 4 times higher.
as high as before. And let's see what happens. And there it goes. Okay, it definitely goes further.
So he was only going, the car's velocity wasn't twice the velocity. It was 1.4, so it was much less than twice the velocity. And yet he got twice the distance. So this would indicate, oh wait, there's more energy. There really wasn't more energy. It just proves that friction is going to cheat and give the lighter, faster object, the faster object, in this case it's not any lighter, advantage. It'll go further.
But how much further? Okay, so we've got about 11.5 feet there. Okay, so what does this mean? So
this means is exactly, human beings just keep replaying the same bad movies over and over and over, the same bad themes, the same bad stories. So 200 years ago, 1740, this was done, and the world said, oh yeah, it's mv squared, because they did some rickety experiments that fooled people. Okay, so instead of answering the question, does it really take 4 times more fuel for my horse to go twice as fast and all that kind of stuff, instead of answering those questions, they just gave up and said, oh well, that's the answer. We did an experiment, it looks right, that's the answer. Even though it creates physics that doesn't make any sense, and now we have perpetual motion machines, theoretically, and free energy machines, theoretically, that nobody can build. So in spite of the fact they say it's certain science, it's the truth, there's no evidence of it being the truth because it clearly states perpetual motion is possible. Leibniz, the inventor of this kinetic energy theory, made this argument. If you believe in momentum, he said, well, then it's free energy. It makes free energy. And obviously from the momentum perspective, kinetic energy has to make free energy, because you're breaking thermodynamics. You're breaking the law of conservation, because you can't conserve both when you change the mass and the velocity. You can't do it. So unless you invert it, unless you do perfect circumstances, only once a day is the broken clock correct. And kinetic energy only gets right answers when you break the clock.
Apparently gave the car twice the velocity. It only went about twice as far. So
and it was going less than twice as fast. So again, you just did an experiment proving the kinetic energy theory, not proving the momentum theory. And unfortunately, again, the proof is just based on ignoring the fact that friction isn't a fair force.
Would mean that this is more closer to being 1/2, not even that, it just says mv, right? Because if it was mv squared...
Yes, what energy was for Descartes, Galileo, and Newton. Descartes, Galileo, and Newton all understood energy was momentum, okay? Quantity of motion. That's all they cared about. That's all they followed. That's all they logically watched in the universe, and they got right answers. That's why they're infamously famous. I mean, they're just gigantically famous. It's because they got right answers, not because they got a bunch of wrong answers. So before, and this is after them, okay? So you kill Newton and you kill Galileo and you kill Descartes and you slander them and say they were wrong about something, and yet nobody ever proved they were wrong about anything or that any of their logic failed. So this is just some sort of invention for the purpose of fixing something that wasn't broken. Descartes and Galileo and Newton weren't getting broken answers.
It should have gone 6 times the amount that...
So 6 is, I don't know where you got that from. That would be multiplying 3, so I don't, that wouldn't be even that. I don't know where you got 6. It would be 4 times.
The single velocity, initial velocity, with it, so it should have gone 24 feet, and I don't even have 24 feet here, so it obviously didn't.
Yeah, so no, it'd be 4 times 16 feet, right? 6 feet, no, it'd be 24, 4 times 6. So he just said it wrong. 6 times, he said, instead of, it would go 6 feet 4 times.
Do that. So, I would have to say that this little experiment what kind of confirms Gary
is more noise. Okay, yeah. So we're all trying to do something to make this clearer and to clear things up and all that stuff. And I'm just going to go back to, it's so much easier just to do it theoretically. We know there's no perpetual motion machine. We know there's no free energy machine because millions of people have tried to make one and they can't. So we know that no matter what theoretically we're going to talk about, it has to be consistent with the fact that that shit can't exist and we know it. Okay, thermodynamically impossible. And so start there, okay, and then argue the theory. Is there any theory for where this extra energy would come from? There's no theory for it.
suspicion that kinetic energy is really like MV because it doesn't look like it.
Yes, energy is really MV. There's no point in saying kinetic energy because that's what you're calling the opposing theory. That's what you're calling 1/2 MV squared is kinetic energy. So you can't really fix kinetic energy. It has to sort of be killed. And we have to come up with a new word because kinetic energy will always be tainted by the notion that that means 1/2 MV squared. So whatever, realized energy we could call it. Active energy. So we just call it active energy is momentum.
It was MV squared here. Now, I haven't done any, I haven't examined the frames or made any careful measurements of how my car works or whether the ramp is perfectly.
Right. And you haven't really watched too many of these videos and you're really not, it's okay. That's the fact of it is, I guess anybody coming into the conversation is going to just come in with their perspective. But yes, we've already been there and done this. Okay, you have to account for these facts that are easy to overlook, and we're all kind of prejudiced in what we again have overlooked. I would argue that Stephen Bro has been incredibly prejudiced in what he cares to overlook in terms of the variables that go into these experiments. In the example of creating free energy with cards banging into each other, they're conceding that elastic doesn't mean elastic. Okay, elastic really does mean elastic bands or some other storage device. You have to put a spring or an elastic band to call it elastic. So two steel balls hitting each other isn't elastic, even though it does conserve all the energy and doesn't lose any energy. They're arguing it's not an elastic. It's not elastic. It's just, there has to be agreed upon elemental fundamental facts, and there aren't any agreement, and our individual knowledge bases are all different, and it creates chaos. So I just say, all I care about are my arguments, right? The lever argument seems deadly. I don't see how anybody's ever going to diagram how a lever can create free energy. So go for it. Explain to me how levers work and how they can create free energy. And that works. Because it doesn't. It can't.
Straight or anything like that. I'm going to leave that as an exercise to someone else. This is just a way of demonstrating how you can actually possibly measure this in an actual objective.
Right, so you're using big words, actual, objective, empirical, but you said possibly, so at least that was good. So yeah, this isn't a way to possibly measure because friction isn't fair.
Empirical experiment. So let me know what you think. And try it on your own if you think you can do this experiment better or find out what I did wrong.
All right, well, what you did wrong is you didn't go 4 times the height in gravity to create your energy. So if you want to create twice as much energy in gravity, you have to go 4 times higher. So first mistake. Second mistake, twice the velocity is twice the energy when you're using the same mass, frankly. But regardless. And again, you're relying on friction to be your ruler, and the argument is that friction is a bent ruler. That would be the easiest way to say it. It's a very, very crooked ruler. It sees fat things different than it sees thin things, fast things versus slow things. All right, so I'm glad he's still in the conversation, so that's good. he should by now realize this is more complicated than he thought, because now he's, switched his opinion 3 times. So he went from Gary's right, Gary's wrong, Gary's right. So we're love me not, love me. So, and we're waiting for the love me not to come. I'm just saying it's clearly this is. So I just would say, just if you can diagram how, the spaceship navigation, throwing mass times velocity is what you throw out of a spaceship. You don't throw kinetic energy out of a spaceship. It doesn't work. You have to throw momentum out of a spaceship to turn the spaceship. And the same is true for the lever argument. It's a momentum converter. It can't convert kinetic energy because it ends up making kinetic energy. It fails to convert. All right, let me just do that one. I'll do that one simple analogy, and that should be enough for Franklin. Well, he probably didn't watch this video, but it's too long. All right, I think it's just logically undeniable that there'll be a certain event that would happen. Okay, so I put a 5-ton train here, and I have another side of a lever that I'm going to bang the trains into the lever. All right, and so I have this fulcrum. Okay, well, that's probably not perfect. I can make that a little longer maybe. So this is twice as far out as this is. Okay, so the 10-ton train's going to hit here. So I have a 10-ton train going 5 miles an hour, 5 velocity. And it plows into this part of the lever, okay, the short arm of the lever. Here's the fulcrum. All right, and here's the other arm. Okay, twice as far out, 5 tons. Can anyone really deny that when that 10-ton 5 velocity train hits this side of the lever, it's going to push this one out at twice the velocity, and we're going to have a 10V here? I mean, clearly that's what levers do. This is what they're expert. This is what levers are expert at. This is their function, is to do these simple conversions, to make little motions, with light objects, heavy objects, into big motions with light objects. This will arc at twice the distance that this does in the same time. So this has twice the velocity, twice the distance in the same time. Okay, and that's what will happen because of a lever. And it's that simple. And so logically, what happened when I did the 5, if I do the kinetic energy theory here, then my 10-ton 5 is, pushes in. It only has, let's say it has 100 joules of energy. The argument's going to be that somehow I created 200 joules here. Okay, so kinetic energy says I only need 100 joules going in. So that's all I got to do. I gotta pause. Pen dropping. So all I need is, I take a heavy, slow object going in, and I produce the fast one coming out, right? And I could make this a bullet. So if I went actually 1,000 times further out on the lever, I could actually do the bullet conversion with the barrel of the gun going, 5 miles an hour. I could throw the barrel of the gun here, and 1,000, arcs away, a distance away, I could put the little light, tiny 1,000 times less matter. So I have 1,000 times less matter, 1,000 times further on the lever, and I could actually do the gun barrel bullet thing. And I could create 2,000 joules with the bullet, and I can only use 2 joules to do it. Free energy, monstrous free energy. Every time somebody shoots a gun, they're making tons of free energy, frankly. Anyway, and then if I did the reverse, okay, so so I take the 5-ton and I put it in, 2 notches out on the lever, and I'm going to shoot the 10-ton out. Now I've used 200 joules in, and I'm only going to get 100 out. Somehow my lever destroyed half the energy. Where did it get destroyed? Where's the explanation of the destruction? There's no explanation of it. So one way I make twice as much energy, the other way I destroy half the energy. And again, all I have to do is make this lever 3 notches. And then it's, 9 times. And then I make it 4 notches. Okay, and it's whatever. Not 9 times, it would be 3 times. And then I make it 4 notches, and it's 4 times. 4 would be twice as much as that. Yeah, that's double. Well, anyway, you get the idea, right? All I do is put lighter objects, 1/4 mass out here, okay, and I can make 4 times the amount of energy I put in here. 400 joules. Come on. Come on. Can somebody please answer where I made a mistake here, where I didn't understand, where I'm incorrect, where I'm stating something that wouldn't physically be the reality, that we actually could do the damn experiment, that somehow they logically know the lever's going to fail to convert the momentum. It's going to fail to be a useful tool. The whole reason why it's a useful tool is it turns a big motion over here into a little motion over here at a very high pressure. The whole reason why it works is because it converts momentum. It takes 100 momentums here and converts it into 100 momentums here in a different form, in a velocity and mass switching. And that's what it does. It converts momentum. It doesn't make momentum. It doesn't destroy momentum. No one will answer this paradox of free energy from the kinetic energy theory. No one. Alright, so till the next time, that's enough, I think, and such. So I appreciate Franklin staying in the subject. If you're going to get into a debate, though, I think you really do have a responsibility to address the actual arguments the person makes. The actual specific arguments. Okay, the general, you could say, okay, I'm disagreeing with DraftScience because of some general notion that he's supposed to, I don't know, stick twiddling. But you're not explaining that, oh no, but my argument against it is because sometimes somebody twiddles a stick into their eye. I'm not opposed to it just for the sake of it. I'm not opposed to mv squared for no reason. I'm opposed to it for specific reasons. And you really have to address my specific reasons, or you're not really addressing my specific argument. Anyway. So, this has been a DraftPhysics.com video presentation. Thank you for your attention and such. Blah, 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 blah.